This module, the online training for the ODOT Analysis and Traffic Simulation, or OATS, manual provides details on the data requirements, data resources, and data collection procedures for obtaining necessary data to conduct the traffic analysis and simulation. In this module, you'll learn how to identify the items needed to be field collected for analysis and understand how to field measure necessary data in accordance with ODOT policy. Field observations are critical to obtain accurate results for both HCS and transmodeler analysis. During the field review, the analyst becomes familiar with the general traffic flow characteristics within the study area. Desktop review of the study area through aerial photographs, video logs, or online street view databases should not replace physical field observations. The field observations should be conducted during the AM and PM peak periods to identify areas of congestion, queues, unequal lane utilization, driver behavior characteristics such as aggressiveness, and other general operating characteristics of the study roadways. The information gathered during the field observations will be used to calibrate the analysis to match existing operating conditions for all complex type projects, as well as verify the analysis whenever an existing analysis is done. Traffic counts are required irrespective of the traffic analysis software being used. For projects where certified traffic is being developed, traffic counts are usually part of the certified traffic requests, so it would not be necessary to collect them twice. Existing data, if available, may be used. Data may be obtained from the ODOT TMMS site or through a local agency. Many MPOs have a count database which can be used to obtain the count data. Counts older than 3 years should not be used. Turning movement counts should be collected on a Tuesday, Wednesday, or Thursday on weeks that do not contain a holiday. When a school or factory with shift work is in or near the study area, consideration should be given to collecting counts when the school or factory are operating under normal conditions. Counts should be collected in 15-minute intervals, typically between 6 a.m. and 7 p.m. Additional count periods, such as weekend, evening, or holidays, may be required on a project-by-project basis. For all collected counts, vehicle classifications should be included. If the study intersection is in a downtown area or other high pedestrian location, pedestrian counts should be collected as part of the intersection turning movement count. Traffic counters will only capture capacity which will result in underrepresented traffic demand and thus inaccurate traffic analysis. In these situations, the study intersections and segments will be shown to perform better than reality. Therefore, counts should be adjusted to reflect actual demand. This adjustment can be made in one of two ways. The first method involves collecting queue counts as defined in Volume 2 of the Ohio Traffic Forecasting Manual. The second method involves collecting additional traffic counts at a location upstream of the congested location. If the congested location is the approach to an intersection, it can be assumed that the traffic volume counted at the upstream, uncongested location will have the same directional proportion of left turns, through movements, and right turns as those observed at the stop line, as shown in this graphic. Segment counts are not needed for every study, especially if turning movements can provide adequate count information. Segment counts should be considered at locations where the demand is likely to exceed capacity. Additionally, segment counts should be collected along mainline freeway segments. Provided turning movement counts at all the ramp terminal intersections within the study area have been collected, only one mainline count would be required. The turning movement counts in conjunction with the ramp terminal intersection counts can be used to calculate the volumes of all of the ramps and other freeway segments in the study area. When needed, segment counts should include vehicle classifications and should be collected for 24 to 48 hours in 15-minute intervals. For arterials, when segment counts are collected, the counts should be collected upstream of the back of the queue so that demand, rather than just capacity, is counted. Balancing and smoothing are two processes by which differences in traffic volume data at nearby locations are reduced or eliminated completely. Balancing refers to the process of eliminating the traffic volume difference between 2 points completely. If there are no driveways between two study intersections, the volumes between the intersections should be balanced with differences eliminated completely. A common example of two intersections being balanced are ramp terminal intersections. Smoothing is used to reduce the traffic volume differences to reasonable levels as determined by the forecasters. If a driveway does exist between the study intersections, the volumes may be smoothed so the differences are logical. The scale of the volume differences should be determined based on land uses. For example, a difference of 500 vehicles in the morning peak hour between intersections when a fast food restaurant is the only driveway is not logical. However, a difference of 300 vehicles with a large office park between the intersections may be logical. The needs to balance of smooth volumes is reduced or eliminated if the traffic counts are collected on the same day. Refer to Volume 2 of the Ohio Traffic Forecasting Manual, specifically Section 2.6, for methods on balancing and smoothing volumes. For projects that will include the Simulation Demand Estimator, also known as SDE tool, check with ODOT Modeling and Forecasting prior to the collection of the traffic counts to ensure that all data needs are collected. The SDE tool may require count data outside of the parameters described in the manual. These needs should be discussed at the early coordination meeting. For standard type projects, average speeds and travel time data are not required. For complex type projects, average speeds and travel time data is required for calibration and validation of HCS and transmodeler analysis for existing conditions. Average speeds and resulting travel times for most interstate, U.S., and state routes in Ohio from NRIX or Streetlight. The average travel speed should be attained in 15-minute intervals on a Tuesday, Wednesday, and Thursday over the course of a 1-year period. Where NRIX or Streetlight data is not provided, travel times and speeds should be collected using the GPS-based automated device using True Traffic. The decision to collect travel time information should be made during the scoping process. It is recommended that travel times be collected on an arterial, not for a single intersection analysis, or a freeway project where other data is not available and the demand is known to exceed capacity. At least 5 passes in each direction during each analysis time period is required. More passes are preferred in the event that some runs need to be thrown out. Data should be collected on a Tuesday, Wednesday, or Thursday during a week without a holiday. The floating car technique is the preferred collection method. For this technique, the driver floats with traffic by attempting to safely pass as many vehicles as pass the test vehicle. Q-links are an important metric in the calibration process for both HCS and transmodeler. As defined in the HCM, the back of the Q is the position of the vehicle stopped farthest from the stop line during the cycle because of the red signal indication. Q size is defined to include only vehicles that are fully stopped or traveling 5 miles per hour or less per the HCM. For standard type projects, collecting Q-links is not required. For complex type projects, Q-links should be field measured at intersections where demand is known to exceed capacity. During the analysis periods, observers in the field or using video recordings note the number of vehicles stopped on the approach at the start of the green signal for each cycle. For unsignalized intersections, observations are recorded in equal intervals of every minute. For complex type projects and any other projects analyzing existing conditions, existing signal timings are required for the analysis of all signalized intersection regardless of the software being used. If possible, the existing signal timings should be provided by the maintaining agency. If timings are not available from the maintaining authority, they can be field measured. Over the course of 5 signal cycles, the splits for all movements should be recorded and averaged to determine the existing cycle length, splits, and signal phasing. When measuring timings in the field, 4 seconds of yellow clearance and 2 seconds of all red intervals can be assumed. Based on the measured cycle length and splits over the 5 recorded cycles, it can be determined if the signal is actuated, coordinated, meaning all 5 observations yielded the same cycle length but different split lengths. The signal could also be actuated uncoordinated, which means the 5 observations had different cycle lengths and different split lengths. Alternatively, the signal could be pre-timed, which means all 5 measurements had the same cycle length and split lengths. Pedestrian timings should be included in the analysis at locations where there is heavy pedestrian activity, such as near schools, an event center, or a downtown area. In these locations, The pedestrian clearance intervals should be included in the existing signal timings and incorporated into the existing analysis. The HCM defines free flow speed as the average running speed of through vehicles traveling along a segment under low volume conditions and not delayed by traffic control devices or other vehicles. Free flow speeds are required for both HCS and transmodeler analysis. For ODOT projects, free flow speed is obtained by adding 5 miles per hour to the posted speed limit. For example, a freeway with a posted speed limit of 65 miles per hour will have a free flow speed of 70 miles per hour. Per the HCM, the lane utilization adjustment factor accounts for the unequal distribution of traffic among the lanes in those movement groups with more than one lane, such as dual left turn lanes or 2 or more through lanes. Another case could be an exclusive left turn lane plus a shared left through lane. At some locations, drivers may favor one lane over another in anticipation of a downstream turn. Additionally, some intersections have a through lane that drops just downstream of the intersection. This type of lane can be underutilized if it is relatively short. In both cases, the lane utilization should be field measured for analysis. On freeways, vehicles may favor a particular lane in preparation of a downstream exit. In the weaving analysis and consideration of upstream and downstream ramps for the merge-diverge analysis, HCS will account for the lane imbalance in most situations. However, unequal lane distribution can often be ignored in the analysis for boundary links. If the chosen boundary link has a heavy weaving volume or other factors causing an unequal lane utilization, the limits for the analysis should be expanded. If the limits cannot be expanded past this segment, transmodelers should be used. Most locations will have an even lane utilization, so this data will not need to be collected. This data need should be determined as part of the project scoping. Where unequal lane distribution occurs, the lane utilization factor must be field measured. The field measurement should be obtained during a 15-minute period during each analysis period. From this measurement, the lane utilization for the entire hour can be extrapolated. If the traffic counts were collected using videos, the video could be reviewed to obtain this measurement without being in the field. A series of tables were developed in the OATS manual to summarize the data needs for each facility type. For signalized and unsignalized intersections, which includes ramp terminal intersections, the intersection geometry and configuration must be identified. The number of lanes on each approach, lane markings, and turn lane links can be measured from aerial maps of Google Street View and confirmed with field reviews as appropriate. Turning movement counts could be obtained from ODOT, TMMS, or other local sources, provided the data is not older than 3 years. If they need to be collected, counts should be obtained on a Tuesday, Wednesday, or Thursday on weeks that do not contain a holiday. Counts, including vehicle classifications, should be collected in 15-minute intervals between 6 a.m. and 7 p.m. Segment counts should be collected if demand exceeds capacity at the intersection. For areas with high pedestrian activity, pedestrian counts should be collected. Queue links should be collected on complex type projects when demand is known to exceed capacity. When performing existing conditions analysis at signalized intersections, existing signal timings should be obtained from the maintaining agency or field measured if timings are not available. Lane utilization should be field measured for a 15-minute period during the analysis period at locations where lanes are not equally utilized. When analyzing an urban or rural corridor, the roadway geometry and configuration in terms of speed limits and number of lanes should be obtained using aerial maps or Google Street View and verified in the field as appropriate. The signalized and unsignalized intersection data should be assembled according to the needs summarized previously. For complex type projects, the average speed and travel time should be obtained from NRICS or streetlight data or field measured if this data is not available. The free flow speed for these corridors is determined by adding 5 miles per hour to the posted speed limit. This table summarizes the data needs for conducting a freeway analysis, including facilities, basic, merge, diverge, and weave segments. The speed limits, number of lanes, auxiliary lanes, merge, diverge, weave locations, weave links, and acceleration, deceleration links should be obtained from aerial mapping or Google Street View and should be confirmed with field reviews as appropriate. The ramp terminal intersection information should be obtained according to the needs summarized previously. Mainline traffic counts can be obtained from ODOT continuous counters. If required, counts must be collected for 24 to 48 hours in a 15-minute intervals on a Tuesday, Wednesday, or Thursday during a week without a holiday. For complex type projects, average speeds and travel time should be obtained from NRICS or Streetlight. If not available through these data sources, they may be field measured. Free flow speeds are calculated by adding 5 miles per hour to the posted speed limit.